Hello, my name is Karen Hans, and I am the Salmon Trout Enhancement Program, or STEP biologist, for the Oregon Department of Fish and Wildlife. I have a bachelor's degree from Oregon State University. I've been a fish biologist for 30 years, and I've been in my current position as STEP biologist in the Corvallis District Office located in Adair Village for 17 years. I'm going to talk to you today about what makes a healthy riparian area for fish and wildlife. I'm going to talk about the aquatic ecosystem, the importance of water quality, the habitat features that make up a good riparian area, beavers, and how to manage your riparian zone and the riparian area and the creek on your land for climate resiliency. The Willamette Valley has a variety of fish species that live in our creeks and our streams and our lakes and our ponds. There's about 25 native species and about 25 introduced species of fish in the Willamette Valley. The fish species of the Willamette Valley are driven in large part by Willamette Falls, particularly for migrating fish like salmon and steelhead. There are two native salmon and steelhead in the Willamette Valley. The salmon is the spring chinook that migrate into the Willamette Valley in April, May, and June. They push their way up into the highest headwaters of the large rivers on the east side, the Calpooya, the McKenzie, the Santiams, the Molalla, and they find deep cold water pools, and then they just hold there. They don't eat, and in August and September and October they spawn and die. The other native species of salmonid in the Willamette Valley is the winter steelhead. Winter steelhead will enter the valley in May, June, July, all the way through August and September sometimes. Like the chinook, they push their way up into the highest reaches of the east side rivers and into the west side rivers as well, such as the Yamhill, the Lucky Mute. And there they will spawn and then go ahead back to the ocean again. And unlike the salmon, the steelhead do not die. Both of these species of fish, the spring chinook salmon and the winter steelhead, are listed under the Endangered Species Act as threatened with extinction. Along with the winter steelhead and chinook salmon live an interesting array of what I like to call the little native brown fishes. Starting from the upper left-hand corner and working across is the chiselmouth, the mountain whitefish, the peamouth, the sand roller, the speckled dace, the large-scale sucker, a western brook lamprey, a sculpin, the Oregon chub, a long-nosed dace, a northern pike minnow, the red-side shiner, and the three-spined stickleback. Along with these native little brown fishes, you'll also find cutthroat trout, rainbow trout, and Pacific lamprey. These fish all live in the rivers and creeks and streams and lakes and ponds, including those on your land. Now, a healthy riparian area is going to offer certain components that provide for this high-quality fish and wildlife habitat. One is shade, and that helps to keep the air cool and ultimately the water as well. Cover. And what I mean by that is trees fallen into the river, shrubs, the roots that grow down into the water. All of these provide places for the little fish to hide from the big fish and the birds that want to eat them. So, for example, a log jam or willows growing along the stream side. A healthy riparian area is going to have nutrients that come from the leaves falling into the stream and decomposing. The trees are going to provide bank stability along with the shrubs and the grasses. That in turn will lead to the filtration that prevents sediments, fine dirt, from running into the stream during rain events. A healthy riparian area will have woody materials, and not just trees that fall in the water, but trees that fall along the banks too, and provide habitat for small mammals such as raccoons and skunks, or salamanders and snakes. A healthy riparian area is going to have refuge places, like on the floodplain, where fish can hide, not just from predators, but from floodwaters. And then there's habitat for other species. So there's a whole host of trees and shrubs and amphibians and mammals that will live specifically in the riparian areas because of the habitat, the higher humidity and the cooler temperatures. But there's other animals such as deer and elk that will seek out the refuge of the riparian area when it's very hot outside, for example, just like we do. Now, a healthy, functioning riparian area should look like this. It's heavily vegetated with trees and shrubs and grasses that provide all those functions that we're just talking about. Sadly, many Willamette Valley streams now look like this. They've been cleared of all their vegetation. They've been straightened from their historic winding, twisting, sinuous pattern. Their riparian areas are overgrown with invasive plants like reed canary grass and blackberries, knotweed, and they're not providing that function that fish and other aquatic life need, or to the other riparian zone animals like certain birds, amphibians, reptiles that need that cool, moist climate. Unfortunately, many of our urban streams in particular, but some of our rural streams as well, have become garbage dumps. When we think of water quality, oftentimes in the Willamette Valley, we base it on what salmon and trout need. But all those little native brown fishes that I mentioned earlier, they also need this same water quality. And flow is what keeps the dissolved oxygen moving into the water, what we call entraining. As it moves down over cascades and waterfalls, that dissolved oxygen will diffuse into the water. And oxygen is also linked to colder water. So the cooler the water, the more oxygen. Now, you can do an experiment where if you take a glass of tap water, put it in your refrigerator, bring it down to 40 degrees, and then set it on your countertop and watch it periodically as it warms. And you will see the bubble forms, and it will start to look like a glass of soda water as the bubbles, the oxygen is released and forms bubbles and moves to the surface. A temperature of 45 to 65 degrees Fahrenheit is ideal for salmon and trout. And while fish like dace and red-side shiner and northern pike minnow may be tolerant to the warmer temperatures, they really do prefer these cooler temperatures because the water will have more oxygen. Aquatic life, like fish, also like a neutral pH, just like we do. If the water is too acidic, like acid rain, or too basic, it can become toxic and eventually even fatal to the fish. Turbidity is all about how much dirt is in the water, those fine sediments that run off of uncovered soil that come off of roads when a creek doesn't have adequate trees and shrubs to hold that dirt, and the bank washes away and into the stream. And the problem for fish is just like the same problem that we have if there's a dust storm or the fires that we had a couple years ago, where you went outside and you could hardly breathe. And turbidity in the water will clog the fine tissues of a fish's gills and make it hard for them to breathe. Another problem with that high turbidity is that fine dirt can settle out of the water, and it can bury gravel, and it can form a layer that the water can't get through, and it can suffocate the fish eggs in the trout and salmon and lamprey nests. And it can kill the fry and the small fishes like sculpin that live in those gravels. And it can kill the aquatic insects that the fish need for food. And also there's pollution. And that can come in many forms. It can be the runoff from roads, like oil and gas and antifreeze, copper from our brakes, which are toxic to fish. Recently, there was a case up in Puget Sound where salmon were dying in the rivers, and they found that it was a specific chemical in car tires that was killing that fish. Pollution can also come from our homes, our lawns, where we put on pesticides and fertilizers. It can come from our sewer water, prescription drugs, and even caffeine. There's been cases where the opioid levels have been so high in creeks that there's concern that the fish may actually be getting addicted, because in laboratory experiments, fish exposed to opioid water did show symptoms of addiction. So it's critically important that we keep pollution out of the water. For one reason, is this is the water that we drink. And also because fish and amphibians like frogs and salamanders, their skin is very permeable. So things in the water soak into the fish and the amphibians, and they can build up in their tissues, particularly their fat. And what we have is a situation where it bioaccumulates, where the small fish is eaten by the big fish, by the bigger fish, by the biggest fish. And each time that toxic chemical like a dioxin or a PCB goes with it. And pretty soon it builds up so high that that fish can become poisoned. There's a lot of ways to keep pollution out of the water. And a healthy riparian area with a good ground cover will filter that water and pull out that pollution. There's also retention ponds, or I like to call them detention ponds, because it's where the water goes when it's bad, when it's polluted. And while it's there, there's a wetland complex. And the bacteria in the wetland will actually break down the pollution. that runs off the parking lot, that oil and gas and antifreeze. And then when the water is clean, it can leave the detention pond. And that's why you will see these detention ponds in the middle of a parking lot. And it's also something that farmers can do to decrease the toxicity of the runoff from their properties. Particularly oftentimes dairies and other livestock operations will have some kind of a detention pond to filter the water and clean it before it goes into the creek or the river. So a healthy creek and a healthy riparian area is going to have a robust population of diverse aquatic insects, stoneflies, mayflies, caddisflies, water beetles, dragonflies, and there's different classifications of these aquatic micro and macroinvertebrates. We call them scrapers, filter feeders, gatherers, shredders, predators. And in addition to being fish food, these aquatic insects are a critical component of a stream's ecosystem. For example, the shredders break down and eat the leaves that fall into the creek. And that makes those basic elements of that leaf, the carbon, the nitrogen, the phosphorus, all those elements that make up that leaf are returned to the ecosystem and the most bottom trophic level to be reincorporated into the plants and the single-celled organisms that then will work their way back up the food chain and eventually get to the fish. A healthy riparian area has good shelter, and this is where the fish hide. They hide from predators, and they hide from the raging flows of a flood. Now, this creek scene here, you've got downed tree that's captured more pieces of logs and branches coming downstream, and the fish will hide in that from the things that want to eat them, like bigger fish, aquatic garter snake, or a heron. It also provides shelter from them when it floods. Now, to a fish, a flood is like a hurricane. And a fish isn't going to be out there in the middle of that stream, just like we're not going to be out in the middle of a hurricane, unless you're one of those silly weathermen. The fish are going to be to the sides of that creek. They're going to be where those trees are. They're going to be hiding in the nooks and the crannies and behind things, and to get out of that strong flow. And that's why it's so important to have that zone right there next to the creek, so when the water comes up, the fish can get away from those really strong flows. Refuge areas can come in the form of a beaver pond, a wetland and a floodplain, or a seasonal stream. Now, these seasonal streams are very critical. I oftentimes hear people say, oh, there's no fish in there. It dries up in the summer. But in the wintertime, when there is flow in that stream, that is just where those fish are going to go. They're going to go there to get away from the bigger fish that want to eat them. They're going to go there to find places to be and food and shelter. Little fish like little streams because there's fewer big fish there that want to eat them. And I keep mentioning that because when you're a little fish, everything wants to eat you. And about those beavers. Beavers are a keystone species. And what that means is they're so important to the ecosystem. There's so many other species of animals and plants that rely on them, that they're critical to that ecosystem. Keystone is a word that biologists borrowed from the architects of the stone walls of ancient Rome. And those stone walls would have archways for passage. And up at the top of that archway was the keystone. And then if the invading army was threatening the city, they could reach up and they could pull down the keystones, and the whole wall would collapse and block that passageway. Well, us biologists borrowed that to describe a species that is so important to the local ecosystem that if that species disappears, the entire ecosystem is in danger of collapsing. Here in the Willamette Valley, beavers are a keystone species. They provide habitat for fish and amphibians like frogs and salamanders, for reptiles like turtles and snakes, for waterfowl like ducks and geese, and other birds like sandpipers, wading birds, and for mammals large and small. Beavers are very kind and altruistic. They will share their lodges and their burrows with muskrats. And deer and elk in the heat of the summer will come to the beaver pond for water and for shade. Beavers will also dig trenches that deepen the water in the pond. And the reasons that beavers build the pond is to protect themselves from predators. But these deepened trenches will also connect to groundwater. And then, as the summer wanes and the rain has not fallen for many months, and there's less and less water in the streams and the rivers, there'll still be water in that beaver pond, and it'll be cold water, and that's where the fish will be. Now, beavers are very vulnerable to predation when they're out of the water. They're very slow and cumbersome, but they're very agile in the water. So they build those impoundments so they can get away from predators like coyotes and cougars. And one more thing about beavers, they're exceptionally good at women's basketball. Now, riparian zones, you have this microhabitat. That's where the humidity is higher and the temperature is lower. And that creates this zone where specific plants will grow. Trees like cottonwoods and willows, and shrubs like currants and red osier dogwood and ninebark, and grasses that need that higher humidity and cooler temperature. And that draws in those birds and amphibians that also need that microhabitat environment. Riparian zones can include side channels that connect to the creek in higher flows. And these provide valuable refuge areas for fish seeking to get away from those raging flood waters. And then there's the floodplain. And in the Willamette Valley, many streams have been straightened and dug deeper, and they have these steep banks. They're incised, as we call them, and they're disconnected from their floodplain unless we get a really big event. Now, this picture was taken during the '96 flood. And these floodplain connections are invaluable to the fish. They move out of that stream and they expand out across the floodplain, and they eat those terrestrial insects and bugs and grubs that they normally don't have access to. And then, as the floodwaters begin to recede, the fish will feel the flow change. They will sense that the water is getting more shallow. They will hear where the cascading water is going back into its stream or river, and they will follow it out of the floodplain and back into the main channel. And that's why after the floodplains recede, when you go out into places where there's water impounded out in the fields, you rarely find native fish in those places because they know that the water is going down and they need to get back to the river. So a healthy stream has structure, what we call structure in it. And that can be woody shrubs like willows. Now the willows along the bank, oftentimes they have a carved out area underneath them that we call a cut bank. And then their roots will go down in this mass of fine root structure. And that's where the little fish will get up in there and hide from the big fish that want to eat them. And there'll be food up in there because that's where the aquatic insects will go too. And then you can have log jams. And there's nothing more valuable to a stream or a river in the Pacific Northwest in terms of fish habitat. Log jams provide an invaluable function that for fish habitat both in the wintertime and in the summer. In the wintertime, it provides a place for fish to hide from the high flows, just like a picture of that stream I showed you earlier. The fish will get right down there in between those logs in the quiet waters. And it will also push the water out onto the floodplain and increase the fish's habitats. And then, as the water is slowed down by the log jam, the gravels will fall out and form a large pile or a gravel bar just above the log jam. And then, as the water goes over the log jam, it will scour, it will carve out a pool. Now, I can be walking down the river in August, and I'll be ankle deep in water. I might be walking on dry gravel. But the water is still there. It's just what we call subsurface. It's gone down into the gravel, and this is where it gets cold. One time I came upon a place in the Willamette River on a side channel, and the water in the side channel was 78 degrees. And there was this spring, if you will, this water flowing out of this gravel bar that had come from the Willamette River and traveled through this gravel, and I put my thermometer in that water and it was 60 degrees. Almost 20 degrees Fahrenheit less from going through that gravel. And so in the summertime, as I walk down that river in that shallow water and I come to a log jam and I'll step in it and I'll be waist deep in water in that pool under those logs. And I can feel the water is colder on my feet. So these log jams are the single most important component of a healthy riparian area for an in-stream habitat structure. Now sometimes, especially in the urban environment, we just can't put logs in the river. There's a lot of concern that the logs will break loose and go downstream and perhaps damage a bridge or somebody's property. And that's correct, because that's what logs do. Historically, there was anywhere from 50 to 80 log jams per mile of stream in the Cascades and the Coast Range. And these logs were constantly being moved around and washed downstream and reformed into new jams. And that was okay because there was nothing in its way. But now there's too many places that we just can't let that happen. So in the lower right-hand corner is a rock dam, small. It's not blocking the water. It's called a weir. And it's providing some of the function of that log jam. It's slowing down the water so it will retain gravel, and it's creating a pool on the downstream side. And this way we can still provide some of that function of a log jam without the risk of those logs washing downstream. Fish passage is a huge issue. Fish need to move for a number of reasons. Some fish, like salmon, trout, large-scale suckers, Pacific lamprey, they need to move upstream to spawn. They live in the large rivers. The salmon and steelhead and Pacific lamprey, they come back from the ocean. They need to go upstream to spawn. And dams and culvert can block their way. Fish also need to move to seek out colder water in the warm summer months. They need to migrate to look for food, to get away from predators. And dams and culverts can block their way. Now, this culvert down in the lower right-hand corner is a classic example of what happens when a culvert that is too small is placed into a creek or a river, an undersized culvert. And what happens is when the flows are high, the water backs up behind the culvert because it can't get through fast enough. And then it creates this pressure on the water, and it comes shooting out of that culvert like a garden hose. Think fire hose. And what ends up happening is it scours out underneath the culvert. Now, when this culvert was originally installed, it may very well have been at the same level as the creek bottom. But over time, that force of that water scoured out under the culvert, and now it's perched above the stream level. And it's blocking fish passage, especially in the summertime when the water is really low. And in the wintertime, the water's simply going too fast, too strong for the fish to try to swim up it. And so undersized culverts are a huge problem. And sometimes a landowner may have a low water ford crossing or a driveway culvert, and it's been undersized, and they don't realize that it's blocking fish passage. But more than that, an undersized culvert is always at risk of failure because it can overtop and it can take out the road, your driveway culvert. And imagine what a nightmare that would be if suddenly there was a 6-foot wide, 5-foot deep gaping hole in your driveway and you couldn't drive to your house anymore. And so a properly sized culvert that matches the width of the active channel is important not just for fish passage, but for the integrity and the lifespan of your culvert as well. Critical to good fish habitat and all aquatic life are these areas of clean gravel that I talked about earlier in terms of the log jam and the gravel bar that backs up behind it. And there's the effect of cooling the water that I talked about that's really important to maintaining that water temperature below 65 degrees. But gravel is also where fish spawn. They make a nest in the gravel we call a red. So the salmon, the steelhead, the rainbow trout, the cutthroat trout, and the Pacific lamprey will all build a red in the gravel. But other native brown fishes, like the large-scale sucker, they will broadcast spawn their eggs over gravels, and their eggs are sticky, and they'll settle down into those gravels and stick to them until the egg hatches out and becomes a fish. There's also the insects that live in that gravel that I mentioned earlier, and that provides for breaking down the leaves and the sticks to provide the nutrients to the basic trophic level of the ecology of the stream, all the way up to providing food for my fish. So water quality issues can come from surprising places. And many of you live in what would be called rural residential areas. Now, this is a graph of water quality measurements from the Little Washougal River. And it includes temperature, dissolved oxygen, nitrates, total phosphorus, and fecal coliforms. And now fecal coliforms can be like, we all know about E. coli, which can make people very sick. But other forms of E. coli can also make you sick, and food poisoning. And so if you notice about this graph, the E. coli is skyrocketing in the summer months. Now we think in terms of higher flows diluting pollution. The solution to pollution is dilution, as they like to say. And so it's not surprising that when the water is lower, the fecal coliform level is going up. However, the source of that fecal coliform is what's interesting, because the Little Washougal River as a watershed does not have a lot of agriculture, and the traditional source of E. coli in the streams, livestock, manure piles, cows wandering in the river and doing what cows do. The upper part of the watershed is timberland. The primary suspect of these high E. coli levels, these fecal coliforms, are leaking septic tanks from rural residential houses. And that's why it's so important that you make sure that your septic tank is properly functioning. Because it doesn't matter how many trees you plant and shrubs you plant and log jams you put in your creek. If your septic tank is leaking and putting E. coli into the water, you're not going to have that superior water quality that you need for a healthy in-stream aquatic life and riparian area. So this concludes my talk, and will be delighted to entertain any questions that you might have on how you can develop and restore and maintain a healthy riparian area. Thank you.